Hello sailors, I'm Naomi, also known as the Desert Sailor with BoatLove.com. And I have created this coastal navigation practice question series in order to help you ace your exam. So, if you've been watching some of the other videos, you'll know that these questions are pretty advanced, so I'm already assuming that you know how to do all of these things. And if you don't, maybe it's time that I make a basic series. Anyway, go back, brush up on these things, and come back and practice with us. So today we're going to cover how to figure out the geographic range of an object when it doesn't fit exactly on the table. Okay, not your dinner table, but the geographic range table that you find in the list of lights only has a certain amount of numbers in it, as you know. And so if your height of eye and the height of the tower are in between those, how do you interpolate the numbers in order to find the correct geographic range? All right, this is going to take a lot of math, so be patient with yourself and let's look at the formula.
So this is the kind of question that you would be using this with, is a sort of a bobbing of the light question, where you're looking at a buzzard. This says Buzzards Bay entrance light, and it's several miles ahead, and you're standing in the cockpit seats, and you places your eyes at 12 feet above the water. And as you strain Buzzard's light, gradually you begin to see its glow on the horizon, and you cannot pick out the light. Then you see its characteristics flashing again, and then you don't see it, so it's going up and down, up and down. So you're going to be dealing with a geographic range situation, which is when you would be using this table, which you would find in your light list. They have this table. Let's cover how you find the geographic range if it's not actually listed in this table. So here in this table, it will give you 5 feet, 10 feet, 15, 20, but what if the tower that you are looking at is, say, 67 feet? And what if you standing on the bench in your boat, you determine you're at 12 feet of your height of eye? Here at Buzzard's Light, it says that its height is 10 feet. No, sorry, 101 feet. 101 feet. But when we checked the light list, it's actually been corrected to 67 feet. So we're at 12 feet and it's at 67 feet. So we're in here somewhere at 12 feet and the light is somewhere in here at 67 feet. And the actual distance would be us, my height of eye, to the height of light, or tower, I guess, height of the tower. And that would be what it is. So, okay, so here's the formula to figure out each one of these. It's a big algebraic formula, and it goes something like this. Y equals y1 plus x minus x1 divided by x2 minus x1, and that is multiplied by y2 minus y1. That's the formula. But where and what are all of these in our situation? So I'm going to say x, x1, x2, y, y1, y2. Y is what we want. Why? Because x is actually what we're asking about. So that's 12. So this is going to be for our height of eye. This is us standing in the cockpit. So your x1 is going to be, oops, this should be in here, sorry. You guys probably saw that earlier. Your x1 is going to be 10 and your x2 is going to be 15. and then the related heights for that. Y is 3.7 and 4.5 for Y2. All right, now all you have to do is start filling them in. I'll do this, but then I'm probably going to rush through it so you see the end of it. All right, let's do it. Y equals Y1 is 3.7 plus X minus X1. X minus X1. 12 minus 10. X2 minus X1. Y2 minus Y1. Twelve minus 10, 2. 5 minus 10, 5. And that's times 4.5 minus 3.7, 0.8. Let's convert this into a decimal. .4 times 0.8, 3.7 plus 3.7 plus, this is a times, sometimes confusing to put the X there, but I guess you could continue just to do that, making sure that that's times 0.8 equals 0.32. And then 0.32 plus our 3.7 is 4.02. Or just round it up, 4.0 feet, nautical miles. Sorry, nautical miles. At our 12-foot height of I. All right, then you have to do the entire thing again, but for the tower. Okay, so let's look at our figures. We are looking for the tower, which is 67, we said. That's what we saw in our light list, 67 feet. And we want to know how far that is in its geographic range. And then, so at our x1, which is the number above, which is 65 feet, and the number below, which is 70. And at 65 feet, it's 9.4 nautical miles. And at 70 feet high, it's 9.8. Let's do the math. Okay, here's the formula. And if you need to pause the video to write it down, y equals 9.4 plus 2 divided by 5 times 0.4. Y equals 9.4 plus 0.16. Add that together, and your geographic range of your height of light is 9.56 nautical miles. Add your height of I and your height of light, and your nominal range of Buzzard's light is 13.6 nautical miles. I hope that helped. I know it's a lot of math. As promised, let's look at how to find a light on the light list. Go to your browser and search for Light List, USCG, United States Coast Guard. Scroll down. I use the Maritime Safety Information publication. When you get there, scroll down and find the publication volume that you would like to download. In our case, it's the Atlantic Coast. You can scroll through all the awesome things that this particular publication has, including our geographic range table we were just using. To find the light, just search in the document, in our case, Buzzard's light, and it'll show up in the index. In the index, you'll see a corresponding number. If you can't find the number in the whole document, you can search for that too. Once you've found it, you can see all the characteristics of this particular light, and we can see the change from the 101 feet on our chart to now 67 feet for this light.